on this Corona module working with FrSky. A couple of people have noticed glitches in the previous video, which I've now fixed the bug that was causing that, and I thought I'd also show how the programming works. So you don't have to solder a header in, but if you want to, that's where the header solders, where all those wires are going at the bottom, and that's connected via that to a USB ASP. Must be a 3.3 volt one, or you're going to damage the module. I'll show you it working next, so we'll disconnect the USB ASP because it's already got the program in. So I'll just disconnect that and put that out of the way. Now the other wire we've got connected here, it's also got a serial port on it. So those three wires are going to this little FTDI serial port adapter, which is also a 3.3 volt one, although it doesn't matter because I'm not powering it off that at the moment. And the only other wires we've got are these, what would normally be internal when it's plugged in. We've got a ground, a supply which is coming from the transmitter battery, nominally 9.6 volts, but anything over 4 or 5 would be okay, and the ppm signal. And I say if it's plugged into the transmitter, it would just pick those pins up. I'm using this old gold transmitter. So let's show you that it's glitch free and show you the serial data. So I've got a different receiver this time. Bear with me while I plug it in. I've already bound it, but I showed you all that last time. So different sort of flashing on the on these V8 V8R7. We get a flashing red light, meaning no signal. Switch the transmitter on, which powers up the module, and we've now got a green light. And as you can see, completely glitch free. That's elevator, I think I've got on that one. Now, the way we program it, just use the Arduino interface. So I'll start up Arduino. I'll put that over on the other screen so that it's out of the way of the transmitters. So if I just zoom in a bit, I'll show you the settings you need for compiling this. So you need to install the 80 mega 48 board. So you go under boards. If it was on something else, let's put it on something else and then I can show you. So if we got an Arduino Uno, for example, right, so what you have to do is under File, Preferences, you see that line there, just do the usual thing, go and search for 80 mega 48 and paste the line for it in there, and then under where is it under, you go to Boards Manager, and you'll see that's the package that you've installed. Arduino Mega AVR boards, and I'm on version 1.8.6. and when you've installed that, then you can go to Tools, Board, and you'll see this other thing called Mini Core, and under Mini Core you go and select 80 mega 48, and there are lots of options for that which seem to reset every time you use it. So under clock, you go for external 8 megahertz. Under brownout detection, you can leave that on the default 2.7 volts. EEPROM retained, although it doesn't seem to always retain it in my experience. It doesn't matter. Compiler, this is the optimization, and it's better to put it on if you've got a reasonably fast computer. So we've got compiler LTO, I think it's a link time optimization or something like that, enabled, and the variant you need for the Corona module is the 48/48A. It's not a 48p. And then once you've done all that, just compile it in the normal way. If we go, I've got verbose. What have we got here? Oh yeah, I tried to upload it. Don't want to upload it, I only want to compile it. I've got verbose switched on. But you can see it ends up using 87% of the available 4K of memory. So while we've got the Arduino fired up, I can show you if we go to Tools, Serial Monitor, that's what the thing prints out through this serial connection. So what we've got there, if I just reset it, it's showing that, can you see that? It's showing that it's receiving 8 channels. Those are the channel values, 1540 microseconds for the first channel, and so on across 8 channels. The numbers it puts in parentheses are the minimum and maximum values it's seen for channel 1, channel 0, the first channel. So you can see we've got a 1535 to 50, we've got about a 15 microsecond variation it's seen there. But of course I haven't got the, anyway, it's not enough to make it jitter. Those are the numbers I put in to find out why the jitter was. The other numbers, the 23536 is the transmitter ID it's chosen, and the 63 is the fine-tuning value we've ended up with. It'll be different on yours, of course. So I suppose why have we not got a green flashing light at the moment? What have I done wrong here? Is it just that the battery's running low? I'll stop it a minute, get it going again, and I'll show you something else. Okay, it's a bit later now. It was just a battery, and I've swapped to a different one. So we're working again now. And the other thing I was going to show you was, because we're printing all these numbers to the serial port, and a lot of people don't know about this, but the Arduino IDE has also got this thing called serial plotter as well as serial monitor, which shows the results graphically. So if we do that, let's come up over here in this window, and it shows the values up at the top. And if I wiggle the sticks around now, you can see red is the aileron channel and green is the elevator, and this sort of yellowish line is the throttle. Purple is rudder. I'll just put the throttle down towards the bottom. Don't know what else we got on here on this old set. Oh, there we go. That must be what was it I moved there? One of those must be gear channel or something like that. There it is, that one, isn't it? That's gear, and you've got these other two slider things, haven't you, on the old gold? And that's another blue channel, and that's black, I suppose. Anyway, it's just something that's interesting to play with if you ever got something outputting serial numbers. Okay, well, thanks for watching.